In this video, we are going to talk about the concept of extreme point. So let X be a subset of RL, which is a convex set. Now a point X, element of the larger X, is an extreme point of the big set X if there does not exist distinct points Y and Z in our parent set X, and we have some arbitrary number lambda which belongs to the open set 0, 1, such that X can be written as the weighted average of Y and Z. So it says that X, this little x, will be an extreme point if this point cannot be represented as a convex combination or as a weighted average of any other points, say Y and Z. A visual example would be, let's say if we have this circle and this is a convex set, and now let's draw two lines here. So if we pick any point, let's say this point, then this point can be written as a convex combination of this point and this point, and hence this is not an extreme point. But let's say if we pick this point, then this point cannot be represented as a convex combination of any other points within this set. We cannot connect any two points which is going to be equivalent to this point, and hence this is an extreme point. Another example would be if we think of this two-dimensional real space, and if we have this intersection of these two lines, then only these four endpoints on this on this set, which represents the intersection of these two lines, will be the extreme points of this set. So here only the four red points are extreme points of the set comprised of these two lines. So this has been the concept of extreme points.